Hi class, this is Dr. Karsten, and this is a continuation of lesson 14 from Module 5, Grade 4, EngageNY Math. I got better. I caught it right away and I was able to save the video. The whole thing is uploaded right to YouTube for you guys. So I am literally just going to pick this up right where we left off. So if you are jumping into this video first, there are two videos that you need to watch before this. First, you have to watch the 3 tricks for comparing fractions less than 1 video. That video gets you ready for this lesson. Then you have to watch the video, the part 1 for lesson 14 video, and then you should only watch this video. Do not watch this video and jump in right here. You will not get it. You will be confused. It won't make sense, especially because I'm jumping right into the middle of this question. So again, this is from lesson 14 problem set. This is question 3C, and we already did the mathematical proof for showing that 1 and 3/4 is greater than 1 and 7/12. And we did that because we saw that 4 and 8 are related. They have related denominators. Because 4 can be turned into 12ths, 4ths can be turned into 12ths. And so we went ahead and did that. And we actually did it by ignoring the 1s and just focusing on 3/4 and 7/12, and turning the 3/4 into 9/12, and then saying, well, when my denominator is the same number, that means my pieces are the same, and having 9 of them is clearly more than having 7. So then 3/4, which is equivalent to 9/12, would be greater than 7/12. And then we threw our 1s in there. And the reason we pulled the 1s out was since they both had 1, we could kind of ignore them while remembering that they were there. So we didn't have to use them for the comparison. We just had to use the part that was different, which was the fractions. So then I had started already drawing our tape diagrams because part of the instructions for this problem was to model it with a tape diagram. So what we did was for 1 and 3/4 and for 1 and 7/12, I drew 2 tape diagrams, each of which represents a whole. Let's just start off with that. Now, since I have 1 and 3/4, I modeled this first one, and I'm going to shade that whole thing in because that's the 1. That's the whole. And also for 1 and 7/12, I have a whole. So again, that's what's the same about them. This is what's different, is the fractions. So now what I want to do is I want to first model 3/4. And I'm going to do that by going ahead and I'm going to turn this into 4ths. And then I'm going to go ahead and I'm going to shade in 3 of those. And I'm just doing it lightly because I am going to be putting in some dashes. And now let's do 7/12. So if I'm doing 7/12, I can actually start out with those 4ths, but then I know that when I turn my 4ths into 12ths, I multiplied by 3 before, so I have to turn each one of these into 3 sections. So you can see I'm making 3 in each of them. So I don't know if you can still see where those 4ths were, but we're going to be doing it up top also, but I'm just going to emphasize those for you. But these are really 12ths. And then I need to shade in 7 of those because it's 1 and 7/12. So we have 1, and here come our 7/12. So I have 1, 2, 3, 4, 5, 6, 7. And now you can clearly see that the 7/12 ends there, whereas 3/4 is here. But again, let's model what we did, which was we turned these 4ths into 12ths. And the way we did that was by multiplying the numerator and denominator by 3, which tells me that I have to decompose each one of these into 3 pieces. Let me just move this over. So I'm going to go ahead and do my best to do that. And you can see how it's just aligning itself with the tape diagram below. And that they look really similar now. So now what you can do is you can see that the 3/4, 1, 2, 3, turned into 1, 2, 3, 4, 5, 6, 7, 8, 9 12ths. And I didn't split this one up, but if you wanted to see that it was 12ths, I could do that too. There's like this hair here that I just can't get rid of, and now I smudged it. Anyway, so now if I look, I just modeled also in there how I turned 3/4 into 9/12. I'm modeling it here where we turn 3/4 into 9/12. Okay, so now let's do a couple more examples, then you're going to be off on your own. So let's go to the next problem, which is problem 4. And I'm going to do 2 of the problems from problem 4 with you, and then you're going to be on your own for problem 5 completely. So let's go ahead and let's take a look at problem 4. And it says, draw one number line to model each pair of fractions with related denominators. And again, we're using greater than, less than, or equal to compare. Again, I'm really kind of emphasizing the math with you this time, but I am definitely going to also draw the number line for you because I do want you to know how to do both of those. And I just have to kind of adjust my paper and adjust the camera too. Okay, so if I want to compare 2/3 and 5/6. Again, my numerators are not the same, my denominators are not the same, and I do not see an easy way to turn 2 into 5, but for 3, if I think of my multiples of 3, I can think of 3 and 6, and there you have it. I can turn my 3 into 6. Now, some of you guys, again, you're not going to be real comfortable turning thirds into sixths on a number line. And so I want to remind you that we can do it mathematically also, where I can say, well, how would I turn my 2/3 into 6? So we know we want to turn our denominator of 3 into 6. What would I have to multiply 3 by to turn it into 6? And hopefully you're telling me 2. Or 6 divided by 3 would give me that 2. Whatever I do in the denominator, I must do in my numerator. So 2 times 2 is 4. So now I do know how I could turn that 2/3 into 6. And that would be by multiplying or decomposing each third into 2 pieces, because 3 times 2 is 6. Let's go ahead and let's draw a number line. Or actually, before we do that, let's compare it. So now if I know that 2/3 is the same thing as 4/6, I don't know if you can see that, I hope you can. So now I'm comparing 4/6 and 5/6. Well, the denominator is the same, so having more pieces is going to be more. It's going to be greater. Okay, so let's go ahead and draw ourselves a number line. And let's start again with those thirds. So first I'm going to just put my end benchmarks in, because I think if I put 1/2 in, it's going to throw us all off since we're dealing with thirds. I'm going to do my best to try and make this into thirds. So 1, 2, 3 sections. So that's 1/3, 2/3, 3/3. I'm going to make these bigger than what I'm going to make my 6th. And the first number was 2/3. So I'm going to go ahead and mark that as being 2/3. So now I want to put 5/6 on there. Well, what I learned before was to turn my thirds into 6th, I had to multiply it by 2, which means I need to cut each one of these pieces into 2 pieces. And we've learned how to do that before when we were decomposing. So now I have 6th. So now I would go 1, 2, 3, 4, 5. And this is where 5/6 goes. And so now you can easily see 5/6 is closer to 1 than 2/3, so it is definitely bigger. Another way to write 2/3 would be to say 1, 2, 3, 4/6. All right, I'm going to model one more of these, and that's going to be our last problem that we're doing together today. So let's do 4C. So if I take a look at 4C, I have 2/6 and I have 5/12. And again, 2 and 5 I can see really do not have a great relationship. They do not go well together. But 6 can definitely turn into 12. And if I do my multiples of this smaller number, 6, I can say 6, 12, and there you have it already. So now again, just like I did up there, I'm on the side going to go ahead and turn those 6 into 12ths, because that's what I want to do. So I know that 6 times 2, or 12 divided by 6 gives me 2, is going to give me 12. Whatever I do in the denominator, I must do in my numerator, and 2 times 2 is 4. So now I know that 2/6 is also 4/12. They are equivalent. So what I really have here is 4/12. When I compare 4/12 to 5/12, I know that 5/12 is going to be larger. And now let's do a a number line to model that. So I'm going to go ahead and draw my number line. I'm going to have my 0. I'm going to have my 1. And first I'm going to go ahead and I'm going to draw my 6th in there. I'm going to do the best I can to try and make them nice and even. And again, I'm going to make these more noticeable than when I do my 12ths. So I need to model 2, 6. That's going to be 1, 2. And just to make the point that these are 6, let's count. 1, 2, 3, 4, 5, 6. So it has been divided into 6 equal sections, and I have 2 of them for my numerator. Now I need to turn these into 12ths, and what we know is that I can turn them into 12ths. 6 times 2 is 12, so each one of these has to become 2 pieces. So I'm going to cut them all in half. So let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we did it. And now we need 5 of them. 1, 2, 3, 4, 5. And that's going to be 5/12. And clearly 5/12 is larger than 2/6. It is further away from 0, and it is closer to the 1. Okay, class, so I hope that this was useful and helpful. Your work is that on your own, you are going to finish out everything through problem 5. And problem 5 I didn't do any because it's basically reviewing the concept. Now, if you're feeling really confident with this, you may jump right into problem set 5, and that's like a little Easter egg for those of you who actually made it through and watched the video. You are going to know that you don't have to do all the problems. You can just jump into 5. However, if you are struggling in any way or you feel like it would be helpful to review, the other questions are going to be really super quick, and just do them mathematically for now. I'm okay with that. But go ahead and run through them because it's really not a lot. It's like 4 or 5 extra problems. But anyway, again, if you're feeling really confident, then you can just do the 8 problems that are in number 5, and that's your little Easter egg for having watched the entire video. All right, I hope you guys are having a great day. I will see you tomorrow. Remember, we are not doing a Google Meet in the morning, but we should be able to do one in the evening, and then I will be there in the next day to meet up with you guys. So I will see you in a couple days. Have a great day. Enjoy. Be well, and I look forward to seeing you in our Google Classroom. Bye.